So the first topic that's going to be discussed in the Let's Talk Calculus is how to calculate or estimate distance traveled from a velocity graph. So this would be your velocity over time graph, and the red line represents the movement or the velocity over time of the object. So the area underneath the line is in the velocity versus time graph represents the distance traveled. So that would be all the shaded blue region represents the distance the object travels. So you might be wondering how that represents this. So the light blue will start by finding the area of the light blue or the triangle, because you'd want to split this up because it's in a regular shape, so you'd want to split it up to make it easier to calculate the area underneath. So this triangle is half of the rectangle shown here. So you'd want to use the formula 1/2 base times height, and the base of the triangle is 4, and then the height is going to be 8. So what you do, base times height, you'd want to multiply them together, so you'd get 8 times 4 to get 32, and then since it's a triangle, you'd want to divide this by 2 to get 16.
Now why do you divide it by 2?
You divide it by 2 because the rectangle here would be the full shape, so say this was shaded in 2, and you'd have to find the area of this whole rectangle. You'd want to simply use the area formula base times height, so base times height. But since it's a triangle, it's exactly half of the rectangle, so you have to cut it in half.
Okay.
So then next you'd want to calculate the rest of the area, and this next part's easy because it's a square, so you can just do base times height. So what you do is the base is 6 of this, and the height is 8, so you multiply them together. So it's 6 times 8, 48, and then since you have those two bases, you can just add them up together, and then you get 64 meters. And then that would be your area, or distance traveled.
64 meters in 10 seconds.
Yes, and over 10 seconds.
Over 10 seconds.
Yeah, because of the acceleration, but then the velocity planed out, so it only traveled 64 meters.
Okay.
The next topic we're going to go over is how to determine certain distance functions from certain velocity functions. So this is a pretty clear-cut formula, or formula for doing this. If a body moves a certain coordinate without changing direction, we can calculate total distance. But if it changes direction one or more times during the course, we must find the body's speed. Next, we're going to figure out how to calculate or estimate velocity from a distance graph. So this is a distance graph right here.
Yeah.
So position over time, or distance over time. And we're going to use this to find the distance, or the velocity. The velocity of an object is a speed in a particular direction. So what we do is this object's moving in a particular direction, but since we want to find its velocity, all we have to do is find the slope underneath the curve, which would be these points right here. So we do this by finding the slope. The slope formula is rise over run. So that would be how high, so you pick a point each here to find the slope. And this is easy because it's linear, so you could find the slope at any point. So we pick the first point here. So rise over run. So you do, the rise is 10 over 1 second. So you do 10 over 1, and you just divide it, and that equals 10. And then you do it again. If you wanted to find 20, exactly at 20. You do 20 over 2, which is the exact same thing, and you'd get 10. But because this is linear, it's easy because you can even go to the furthest point. You can go to 100, and you'd still get 100 over 10 equals 10. If you just kept going out this way because it's linear.
Okay.
But if it was curved, that would lead us to the next thing of when can we calculate the velocity, or versus when we have to estimate. We'd have to estimate if, say, it was irregular. So say the graph went something like this. This is being the graph, and this is position over time, and it did something like a quadratic, and it went up. So you have the certain points over here, and the certain distance, or certain time down here, I'm sorry. It'd be difficult to find an exact point and know the exact slope of the point, or even the slopes between the points. Because if you had a full, coordinate system, some of the points would lie in between lines, or somewhere in between. You wouldn't be able to get an exact reading at 20 or 2, or say 40 and 3. It could be at 3.2 or 2.1, And then that becomes you have to estimate, because you'd have to take the slopes at certain points, and you could even cut out a little bit of area and just try to round up and find the points.